All right, so I'm hoping that today is a review for you because you should have already learned this stuff. So I'm going to go by relatively quickly. When you add and subtract, when would you use add or subtraction to solve an inequality? Yeesh, couldn't get that one out. All right, so the high school team can have no more than 26 players on the team. If the coach already has 17 players on his team, how many more players could possibly join? Now, this might seem like a pretty straightforward answer. You say, look, I need an equation to solve this amount. If I want to know exactly 26 players, I'd have 17 plus the number of players equals 26. If I subtract 17, I get 9. I need exactly 9 players to make my exact 26. But this question actually says can have no more than 26. That means that's the maximum I could have, but I could also have less than that. It's possible. So in an inequality, you're going to solve for a range of numbers of answers. So there's going to be multiple answers. And so what you do here is instead of an equal sign, I want to know less than or equal to 26. It can be 26, but it can also be less than that. And so I solve the problem the same exact way, except this time the only difference is my answer. Instead of being 9, it's going to be basically 9 and everything below that. So 9 or less players can possibly join. Again, this stuff should have been talked about in elementary school, but this is just a refresher, okay? So the key concept in solving inequalities with addition or subtraction, here's the algebra, and it says, look, when A is bigger than B, and you add the same amount to both sides, then it stays the same. It still is bigger than A will still be bigger than B, even if I add the same number to both sides. For instance, 5 is greater than 2, and so if I add 4 to both sides, that's 9 is still bigger than 6, so it doesn't change anything. Subtraction is the same. Look, if A is bigger than B and I subtract the same amount from both sides, it'll still remain the same. So for instance, 5 is greater than 2. This time I subtract 1 on both sides. That ends up with 4 is still bigger than 1. So it still stays the same. Okay, pretty straightforward. An inequality is just a math sentence that compares quantities. Compares, okay? And so we're going to have a few words that show up for inequalities. You've got the less than, the greater than, the less than or equal to, or the greater than or equal to. But these are some words that might show up that actually indicate that sign. So if you hear is less than, is fewer than, that's a less than symbol. Is greater than, is more than, or exceeds, that's going to be a greater than symbol. Is less than or equal to, that means you got to put that little equal to. Is no more than, that means it could also be equal to. And is at most, that means it also can be equal to. The last one is greater than or equal to, okay, that gives you the clue. Is no less than, okay, and is at least. And so I do tell my students that, remember, this one is less than, it looks like an L, and this one looks maybe like a G, greater than. So don't forget which symbol is what goes which way. Again, I'm keeping this quick, so be ready for this. We've got x plus 3 is greater than 10. I subtract the 3 on both sides, okay? The x just breaks down. These two cross out. 10 minus 3 is 7. So that means that my answer can be any number larger than 7. So I just choose a number larger than 7. 8, for instance. 8 plus 3, is it larger than 10? Sure, 11 is bigger than 10. So you can choose any number that's larger than 7. Let's take a look at another example. How about this one? What am I going to do here? Well, maybe you realize you're supposed to add 5 to both sides. Here's my variable. I'm trying to eliminate the constant. So I'll add 5 to both sides. I come up with this as an answer. Now, some people have mentioned, hey, Mr. Rollins, can I just flip that around? You sure can. It's basically saying your answer, -1, is greater than or equal to all of your other possible answers. So it's like -1 has got to be bigger than or equal to anything that you choose. I think it's easier just to flip things around and say, okay, well, wait a minute. That just means that n is less than or equal to -1. And it works out either way. So you just choose a number that is less than or equal to -1. So I just chose -2. And I go back and plug it in. -6, is that bigger than this part over here when I plug it in? Yeah, -6 is larger than -7. Yeah, it does work out. Okay. And the last refresher is graphing the inequalities. Remember, we use open circles for less than or greater than. Okay, because we're talking about open circle less than 5, for instance. That means we cannot include 5, but all the numbers less than 5, like 4 or 3 or everything in between, is okay. But you can include it. So that's why it's called an open circle. And then we have closed circles for less than or equal to or greater than or equal to. Remember, if it says less than or equal to 5, that means that, hey, it includes 5 and then also everything less than that. So you see an extra line, you are shading it in. It includes that starting point. If you're not shading a line, you don't see that, it's an open circle. There's the differences. So let's solve this one. Solve and graph. Okay, so here we go. We see here that we're going to add 4 to both, or I'm sorry, subtract 4 on both sides. I get h is greater than 2. So I go to draw my number line and I go to 2. Open circle. Does not include 2, but everything larger than that. And so I shade to the right. It's not inclusive. Let's try one more here. This one looks like you're going to add 6 to both sides. You get x is less than or equal to 10. This time, because it's equal to, it's inclusive. You actually shade in at the point at 10 and everything less than that. All my answers are less than or equal to, so it includes that. All right, that's it for notes today. Hopefully that helps you out. If you need more help, feel free to ask me.